Hey, Cat Math students. This is video notes for percents, ratios, and proportions, objectives 38 and 39. So make sure you grab your packet. If you don't have your packet, hit pause, go grab that. Then you'll open it, the page that looks like this, 38, 39. We're looking at problems involving simple interest and compound interest. So we will talk about what those are in a second here. And we're going to look at just the basic type of problems that those involve. Could be a little bit of review if you've been at Gap a while and you've done some of the financial literacy or what we call money math stuff. What we're going to do first, we have some area for the notes, is you're going to turn the pages a little bit and get to the end of this section. Okay, and we're going to go right here and we're going to do some notes. Okay, so I'm going to draw a line down here as straight as I can. And what we're going to look at first is simple interest. We'll do that over here. And what we're do over here is called compound interest. And I'll explain the difference as we go. Simple interest can be done, and compound interest in a way, it can be done either borrowing money, or a lot of times it is borrowing money, or investing money. So it works for either way. So you kind of probably know interest in some sort of way. You know, if you have a savings account and you put money in there, the money will grow over time, or even more if you're talking like mutual funds or stocks or something like that. But it also is borrowing money. So when you buy a car and have to take out a loan or credit cards and things like that, there's interest involved. Okay. So what we're going to look at is just kind of the basics of those, and you can get way farther into this, and I'll kind of just touch on it, but as far as the problems, we won't go into that. First, for simple interest, there's two main formulas that we'll use. One equals, or is I equals PRT, and the other one's going to equal, or it's going to be B equals P plus PRT. So what these letters mean, okay, the I is going to equal the interest earned or owed. So what that means is if you put $100 in the bank and after a certain amount of time you have $105 in the bank, okay, the 100 you put in there was yours and you have earned $5, and so that $5 would be the interest earned. Or you can look at it the other way. If you borrowed $100 and at the end of a certain time you ended up paying $120, the 20 was the interest that grew in that time. Okay, the B would be the final balance that you either earned or paid. So in those two examples I said, if you put $100 in the bank at the end of a certain amount of time, you had 105. 105 would be the capital B, how much money you actually have. Or if you borrowed $100 and then over time you had to pay 120, that was the final amount that you paid, was 120. Okay. So the other letters are just going to be what important is what's important to solve these problems. P stands for principal, which is the amount invested or borrowed. So in that example, those two examples I set up top, the $100 would be the principal. Rate, or R, equals the annual interest rate as a decimal. Okay, we'll talk about that in a second. And the last letter, T, stands for time in years. Okay, especially in all the problems we work here, that'll be in years. Okay, so that's the formula. And we'll look at some problems here in a second. That's just what the formulas are. Compound interest. Okay, and I'll explain the difference of these two in a second. Compound interest, the balance is going to equal P times, and then in parentheses, 1 plus R over N, and then to the N times T power. And we're going to be able to simplify that in a second, but let me explain what all these are. P is just like on the other side, that's the principal. So amount vested or borrowed. Okay. R, that's the, again, that's the annual percent rate as a decimal. Okay. N is the number of times your money is compounded, and we haven't even really explained what that means yet. Compounded per year. So if they said it was compounded monthly, that would be 12 times per year. For now, we're going to use just 1 time per year. So that'll be that would be what's compounded yearly or annually, just 1 time a year, which is why we're going to be able to simplify this in a second, because that's just going to be 1 in the problems we're doing. Now, over time, or in real life, you'd want that happening more often, and you'll see why in a second. Okay, T is going to be the same thing. Time as number of years. Okay. Now, because for now we're doing compounded yearly, again, you don't even really know what that means yet. So N equals 1. We can use this other formula and make it just a little bit easier. So I'm going to move this up. So if N is 1, the balance can be P, and then in parentheses 1 plus R, because up here R was divided by N. Well, if N's 1, whatever your R is, it's just going to equal that. And then all to the T power, because of N times T, 1 times whatever T is going to be this. So this will be the main one we're going to use. And I'll rewrite that later on. Okay. Now, you'll see in a bit here that compound interest for, especially for investing, is going to be way better. Because what happens if we add time and this is money, what happens here as time goes, your money is just going to climb at a steady rate. Okay. What happens here when it's compounded interest, it's going to look like this. And over time, it just starts climbing more and more and more. So I'll show you, or I'll talk about that on why that is in a second. So we're going to pick up just a few problems to do here. And do the basics. A couple examples here. So go back to the beginning. We're going to start with this problem. It says Miss Abbott loaned her granddaughter $5,500. She charges simple interest rate of 14.9% per year on the loan. To this nearest dollar, how much will her granddaughter owe at the end of the 4 years if she doesn't make any payments? So if she doesn't pay her as we go, one key thing here is they're going to owe at the end of the year. So remember, we had two formulas. We had this one, and we had this one. This one tells us just how much interest is going to be earned. This tells us the full amount either that you're going to get or you're going to owe. So for this problem, we do not do this one. We are going to use this one. So what we know, or we're looking for the balance, the P, principal, is the amount borrowed. And then we're going to plus P again times R. Now, interest rate as a decimal, 1, 2, we got to move that over twice, so it's 0.149. And then the time, they want to know after 4 years. Okay. So, order operations, this stays. We have to do the multiplication first. So we're going to multiply these three items. Okay. And that's going to equal, when you take this times 0.149 and then that answer times 4, will give you this. And then you add those together. And that's how much you end up paying back. So this is why you have to be careful with credit or with interest, and this is why people end up paying a lot more money with credit cards. She only borrowed this much money, but in all, she ended up having to pay this much. So that's a lot of extra money to be able to get the money when you want it. We're going to go to number 71 next. We'll come back and do the compound interest ones. So let's do another one of these. There's going to be a couple things different with this one. So when she left for college, she deposited $3,300 in a savings account. During the 2 years, 9 months that she was at college, her money earned 2% simple interest annually. How much interest did Claire's money earn during the time she was at college? So this one, they only want the interest, so we are going to just do this. Okay, so let's fill in the principal, the amount she put in, $3,300. The interest rate, so remember 2%, you got to move it 1, 2, so that's 0.02. Now the other tricky part of this problem is T is supposed to be in years. We have 2 years, 9 months. Now don't write like 2.9 or something like that. Okay, don't do that. Okay, so this would be good notes here. If we have to change months to years, divide by 12. So if you think about it, if you have 12 months, you divide it by 12, that equals 1. That's 1 year. So what we do here is, if we got to find the time, we have 2 years, 9 months. Okay, so that's going to be 2 and 9 divided by 12 years. So it's not, we have 9 months, there's 12 months in a year. Okay, so then we're going to have 2 point, now to change it to a decimal, you just take top divided by bottom. 9 divided by 12 is 0.75. So we have 2 years. 9 months is 0.75 years. So we have 2.75 years. So that's what goes in for T, 2.75. Okay. So now we multiply these three things together. You get 181.5, or if you're changing it to money, you throw a 0 on the end. And there's the money. Okay. Now, if they asked for the total balance, we would just add this to the 3,300. Okay. I think I'm just going to get you started on one other simple interest one, then we'll look at compound interest. So 74. I'm just going to give you a hint on this one. So first of all, you read through the problem. He deposits 3,700 into account, 5% simple interest rate. He plans to leave the money in an account for 5 years, 3 months. What will the account balance be? So the first thing, when the question is account balance, that means we're going to use this formula. The I equals PRT is if they ask just for the interest rate. So the other thing I'll help, so that's the first thing you do with a simple interest problem, is figure out which formula they're talking about. And then the other thing I'm going to help you with in this problem, and then we'll move on, is just review how to change this to years. So if we have 5 years, 3 months, that means we're going to have 5 for the whole number of years, and we have 3/12 of a year. Okay, so then change the 3/12 to a decimal. 3 divided by 12 is 0.25. And then we have, so the T for this one would be 5.25. So that's what you're going to use in here. Okay, so I'll let you try that one on your own. And then see, you can check your answer in the back, see if you're getting it right. All right, next one we're going to do, I'm going to show you how compound interest works, but then we're going to be able to use the formula to solve these. So the amount of work I do in this one is way more than what you're going to need to do. So I'll show you how to do it the way they're showing with a chart, and then I'll just show you the formula. So what they're doing with this chart, well, let's read the problem. They're going to put 1,800 into account that earns 2% interest compounded yearly and leave it there for 3 years. How much will be in the account at the end of 3 years? So what compounded means is, instead of just taking P times R times T, and every year, or whenever they say, if they say compounded monthly, it would be every month or whatever it is, you're going to reset the money basically. So compounded yearly means we're going to have a new amount starting the second year, because we're going to take into account that interest for the first year. So I'll show you how they get these numbers here. So remember, to get the balance, you are taking what you start with plus PRT. Well, P is the 1,800. R is 2%. Remember, 1, 2. So 0.02. And R would be, or T would be just 1 year. So you could write in a 1 here, but you don't need to because it's not going to change anything because we're doing this for every year. So the time would be after 1 year if it's compounded yearly. So what we do here is order operations, multiply this first. This is, when you multiply that, that's 36. So that's how they get the amount of interest earned is right here. Because remember, this is P plus PRT. PRT is the interest earned. So when they add it up, they get this. Now the point of this is now the second year, you start with this instead of starting with this. So you're already starting with more money. Okay, and again, you're not going to have to do this for other problems. So now, because you're starting with more money, the interest earned is going to be more. Now, right away, it doesn't look like much more. But now we take this 1,836 times 0.02, and instead of earning $36, it's $36.72. Now, again, that doesn't seem like much, and it's not much more. It's 72 cents more that year. But if you had a bigger interest rate, and the more your money grows, that's just going to keep climbing higher and higher. So the interest here earned was this, and it gave us final balance of that. Now, we're just going to do this one more time, and again, you're not going to have to do this for the other problems. We start with this, so now we're even starting higher. And we take that times 0.02. It gets longer to write. When you multiply that, it gives you, and I'll write it all out, but then you'd round this to $37.45. And then you add those together, and you get that. Okay? So now, that's how much you would earn. So now I'm going to show you how to use that formula we did before. So in our notes at the back, to find compound interest balance, we would have this. So we got to fill in the numbers. So the beginning principal is that. We have 1 plus the interest rate as a decimal, which we said here, 0.02. And then the time is 3 years, so that's the exponent. All right, so now you have to use order operations here. So we're going to have that. We add in the parentheses. Now, common mistake here is people will multiply these two. We have to do the exponent first. Okay, so now I'm going to show you how. Now you could take a because it's just the third power, you could take a calculator. Remember, this is not times 3, it's 1.02 times 1.02 times 1.02. You could do that, or even on your calculators on your phone, if you hold your phone upright, you're probably going to only see like the main stuff, like right here. But if you turn it sideways, you're going to see more buttons. If you turn it sideways, you're going to see a bunch of buttons that kind of look like these ones. This is the button that we want. Okay, so when to do these, let me just show you here. The XY button means you would type the first number is your X, so the base. So let me see if we can get, so 1.02 to the third, we would put 1.02, then you would hit this button, okay? Let me clear that. I didn't clear that. Let me clear. Okay, so 1.02, hit this button, and then to the third equals, so we're going to get this 1 Now, instead of writing this out all the time, just leave it in your calculator. Okay, because now you're going to multiply by this 1,800. So don't erase that. Just keep it there. Hit times 1800. And here's the number right there, which if you look at is this, or as a rounded answer, is exactly what we have here. So you don't have to do all this work. You can use the formula. Okay, so I will do another problem with you with that. So let's go to back up to number 69. So if we read this one, they deposit 7,400 in an account that pays 3.25, interest compounded annually to the nearest dollar. How much will they have in the account after 6 years if he doesn't add any additional money to it? So that's the thing with these. It would even climb faster if you added money, but we're not going to do that type of problem right now. So the formula is this. So principal 7,400. The 1 is the part of the equation plus, so if we have 3.25, we're going to go 1, 2. So 0.0325 is the interest rate as a decimal. And the time here is 6. Okay, so the next step in the parentheses, 1.0325. You put that. Okay, so now here is the part where you're going to want that calculator. So we want 1.0325 to the 6th. Okay, so clear your calculator. 1.0325. Again, turn your calculator sideways. You'll see this button. You're going to hit that. Hit 6. Now, I'm not going to write out all these numbers. Okay, but it's, we got 1.2115, whatever. Now the key here is don't erase that in your calculator. If you got that in your calculator, leave it there, and now you're going to hit times your principal, 7,400 equals it's going to be $8,965.449 something. So you round here. They just say round to the nearest dollar. So that's right here. You look at the number next to it. So that's going to be 8965. Okay. All right. Last thing, I'll just give you one more hint on this one. So even though they show this big chart here, I showed you the formula to use, so we don't need to do this. Okay, so for this problem, you're still going to do this. If you hear that noise, that's my dog snoring. But anyways, so I'll set it up, but I'll let you complete the work. So the principal goes there, 1 plus interest rate is 5. So move that twice, it's 0.05, and for 5 years. Okay, so that would be the setup. So that is objectives 38 and 39. Go ahead and give some of those a try. Always a couple things, always make sure, is it simple interest or compound? And then if it's simple, make sure you see, are they asking for the balance or just the interest? Okay, and then make sure you're using the notes that I gave you at the end there. Okay. I think that should be it. I don't know. I guess I can go through and circle which ones we did here. You know, it's kind of easy to tell if it uses the word simple interest, then it'll be simple interest formula. If it uses the words compound, use the compound formula. Those are the 4 problems. Give some of those a try. First of all, take the notes, send me the pictures, try some problems, see if you have questions, and then ask for the test when you're ready. Okay.